Hey guys, we're still looking at lesson 1.3, transformations of function graphs. All right, so the first thing we're going to do is kind of take a peek at the textbook. It has some really good examples here, and we're going to start with translations. So translations is when you're just shifting one function to a new place. So if you look at this first function here, g of x equals f of x plus 2. So you're going to see, if you read through this, take notes whenever you need to, but f of x plus 2 is going to take my original function, and it says right here that f of x is in blue and g of x is in red. So I'm going to take f of x and plus 2. I'm going to move it up, the whole function, up 2 units, and that's going to become g of x. So if you come over here and you can see the blue line, and then that blue line has been shifted up 2 units, and that's what this is in function notation. All right, so you can see that a vertical shift up 2 plus 2 moved it up 2. If this were minus 2, the red line would be 2 units below the blue line. It would be shifted down instead. So the number is outside the parentheses. That is a vertical shift up or down, same as the sign. All right, moving down to the next one, you'll see that this has an f of x minus 2, but the x minus 2 is in parentheses. When the number is inside the parentheses, that tells you that it's a horizontal shift. That means it's going to shift from left to right. And that means it's changing the x instead of the y value. Okay, so here, instead of the output changing, we're going to input the -2 first. So if our input for g is 1, and I go down 2, or subtract 2, then I get -1 for that value. And then 3 minus 2 is 1, 5 minus 2 is 3, and so on. So this is going to be a horizontal shift, and the horizontal shifts shift you opposite the way you expect it to, kind of like in point slope form, and there's some other math formulas that do the same thing, and it's because you're changing the first value before the output happens. So you've got the blue line here is your original line, and you can see it has been shifted to the right 2 units. So I think of it in a positive direction because 0, 2, 4, 6, this is going positive direction. So it's going to go to the right or in the positive direction 2 units. Now, same thing, if this were a plus 2, then it would be shifted to the left 2 or in the negative direction. So again, this one's kind of opposite of what you expect from this sign. But outside parentheses, this is a vertical shift. Inside parentheses, a horizontal shift opposite the direction you expect it to go. All right, the next thing we're going to look at is stretch and compression. All right, still we have f of x is blue and g of x is in red. So you can see this has a multiplier of 2. So this is 2 times f of x. So that means we're multiplying 2 times the y value, because f of x, remember, is just a function notation for y. So you can see here the inputs are exactly the same for both functions, and then the output is multiplied by 2. So -2 times 2 is -4, 2 times 2 is 4, and so on. Okay? Now, same thing. Down here, we've got 1/2 times x, not f of x. So up here we're multiplying 2 times f of x. Down here we've got half of x. So that's why we've got the multiplier for times x, your input. Remember, your input is your domain and your output is your range. All right, so we're going to do each number times a half. Half of -2 is -1. Half of 2 is 1. Half of 6 is 3. Half of 10 is 5, and so on. So you can see how this stretches you here on your y's, and this changes on your x, how long it is on your x. Okay? All right. Last thing is going to be reflections. Same kind of thing. We've got our function f in blue and g in red. All right, if we have negative f of x, that's your y value. So we're going to do negative f of x. So here we've got the same inputs, and then we're going to do negative 2 times negative 1. 2 times negative 1, so on and so on. So you can see that this one, here's your original blue, and it reflects across the x-axis. And then you come down here, and the negative is inside the parentheses. So this time the x is the one that's becoming negative. So we're going to do 1 times negative 1 here. So the x values, or your input values, will change. And that results in a reflection across the y-axis. Okay, so that's going to change it. Here's my y-axis here. So the blue line, if I reflect it, it reflects to the red. So outside parentheses is going to reflect it across the x. Inside the parentheses is going to reflect it across the y. All right, let's look at a few examples. Let's see if we can get through some of these. So it says, for the graph below, the solid curve function is f of x and the dotted curve function is g of x. So you can see solid line, f of x, dotted, g of x. Complete the table. 0, 0, and 0, 3. So g of x goes up 3. So it is 3 units higher. So we go from negative 1/2 to 2.5. That one goes 3 units higher. From 4 to 7 is 3 units higher. So I want you to see that all of the points are being shifted the same amount each time. All right, it says, which of the following shows the correct formula for g of x in terms of f of x? So again, f of x is the solid line, g of x is the dotted line. So this line has been shifted up 3 units. So we need plus 3 outside the parentheses. So let's see, f of x plus 3. These have negatives, so be careful. It's not reflected. It's just shifted up 3. All right, let's look at the next example here. It says, find the relationship between g of x and f of x. Okay, again, f of x is solid. G of x is the dotted line. All right, it says the dotted curve on the graph shows the intermediate step in stage 2 transformation. All right, so the graph of f of x can be, the graph of f of x can be reflected to give you the dotted line, and the dotted curve can be shifted to give you g of x. The point 0, 0 on the dotted curve corresponds to the point. All right, so 0, 0 goes to 0, negative 2. And the point 8, negative 2, let's see, where's 8, negative 2? 8, negative 2 is here. And it's going to go to 8, negative 4. All right, so basically it's just trying to walk you through it step by step. All right, therefore g of x is a reflection of f of x shifted. F of x is shifted up after it's reflected. And then it's shifted up by how many units? I'm going to say 2. Well, it must be shifted down. Let me see if I can look at that graph again. Let's see. All right, so it is reflected here. Which function did it start with? Therefore, g of x, that's why. So g of x is here, reflected over, and then shifted. This one is a little bit difficult to read because you got this extra line in here as well. Okay, so this is the reflection, and then so I was looking at it backwards. This light gray line is the reflection, and then you're shifting it down from there. Okay, I'm back with you. Sorry about that. All right, which of the following shows the correct equation for g of x in terms of f of x? All right, so we said it was a reflection, and it was shifted down 2 units. So a reflection, all right, it's a reflection across the x-axis. So that means the negative is going to be outside, and it's shifted down 2 units, which is a -2 outside the parentheses. So let's see. Yep, there we go. All right, so a couple examples here. As you can see, sometimes you have to read these more than one time because you have to go back and look at the picture and make sure that you're reading them correctly. If you have any questions, please let me know.